In this lesson, we will examine a type of question that tests your ability to transform word problems into algebraic expressions. In the question shown here, we are told that Garth owns a total of X ties and Y of these ties are blue. Our goal is to determine which of the 5 algebraic expressions represents the number of ties that are not blue. Since each answer choice consists of variables, the correct answer will be the one that allows us to determine the number of non-blue ties based on the values of X and Y. In this lesson, we will examine 2 approaches to handling these question types. The first is an algebraic approach, which relies on our ability to translate given information into an algebraic expression. So to solve this question, let's first draw some ties. The question tells us that Garth owns a total of X ties, and we are told that Y of these ties are blue. This means the remaining ties are not blue. So the number of ties that are not blue will equal X, the total number of ties, minus Y, the number of blue ties. As such, the answer here is B. So regardless of the values of X and Y, the number of non-blue ties will always equal X minus Y. Now, the other way to solve this question is called the input-output approach. Here's how it works. First, we choose some actual values for the variables. Let's say that X equals 10. In other words, Garth owns a total of 10 ties. Now, we didn't have to choose 10 to be the value of X. We could have chosen any number to represent the total number of ties that Garth owns. In a later lesson, we will examine some strategies for choosing numbers, but for now 10 is a good value for X. Now let's choose a value for Y. Let's say that Y equals 3. In other words, Garth has 3 blue ties. Now that we have values for X and Y, we can use them to determine how many non-blue ties Garth owns. So if Garth owns 10 ties altogether, and 3 of them are blue, then Garth must own 7 non-blue ties. Now, since the correct answer choice must represent the number of non-blue ties based on any values of X and Y, we are now looking for an expression such that when X equals 10 and Y equals 3, the output is 7 non-blue ties. At this point, all we need to do is check the answer choices and see which one yields an output of 7 non-blue ties when X equals 10 and Y equals 3. So beginning with answer choice A, we can evaluate this expression by replacing X with 10 and Y with 3. When we do this, the expression evaluates to be 13. In other words, when we input X equals 10 and Y equals 3, the output is 13 non-blue ties. Since we already determined that the required output must be 7 non-blue ties when X equals 10 and Y equals 3, answer choice A is not the correct answer. Now let's try answer choice B. Here, when we let X equal 10 and Y equal 3, the output is 7, which is the same as the required output we already calculated. Now at this point, we still need to check the remaining answer choices in case another expression yields the required output of 7. We will discuss this in an upcoming lesson. So let's keep going. When we plug X equals 10 and Y equals 3 into answer choice C, the output is negative 7, which is not the same as the required output of 7. Finally, when we plug our values into answer choices D and E, neither of the outputs is equal to 7. As such, the correct answer is B. Okay, now let's practice our 2 strategies on another question. Here we are told that the base of a rectangle has length X and its perimeter is 10. Our goal is to determine which expression represents the area of the rectangle. Let's begin with the algebraic approach. So here's a rectangle, and we are told that the base has length X. Since the area of the rectangle equals base times height, we must determine the height in terms of X. Well, since the perimeter of the rectangle is 10, and since these 2 sides represent half of the entire perimeter, we can conclude that the sum of these 2 lengths must be 5. So if one side has length X, the length of the other side must be 5 minus X. At this point, we can conclude that the area of the rectangle will be X, the length of the base, times 5 minus X, the height. When we check the answer choices, we can see that the correct answer here is E. Alright, now let's solve the same question using the input-output approach. So let's take our rectangle and choose some value for x, the length of the base. Let's say that x equals 3. In other words, the base has length 3. Now if the base has length 3 and we are told that the perimeter of the rectangle is 10, we can conclude that the height of the rectangle must be 2. From here, if the base is 3 and the height is 2, then the area will be 3 times 2, which is 6. So when x equals 3, the output is an area of 6. Now let's check each answer choice and see which one yields the required output of 6 when x equals 3. Beginning with answer choice A, we will replace x with 3 to see that this expression evaluates to be 1. Since we already determined that the required output is an area of 6 when x equals 3, the answer choice A is not the correct answer. Now let's try answer choice B. Here, when we let x equal 3, the output is 49, which also does not equal the required output of 6. When we plug x equals 3 into answer choice C, the output is 12, which is not the same as the required output of 6. When we plug x equals 3 into answer choice D, the output is 4, which is not the output we are looking for. And finally, when we plug x equals 3 into answer choice E, the output is 6, and this does equal the output we already calculated. As such, the correct answer here is E. Alright, let's summarize. In this lesson, we learned 2 approaches for handling questions with variables in the answer choices. One strategy is to take an algebraic approach where we directly translate the given information into an expression. The other strategy is the input-output approach. In this strategy, we first choose values for the given variables, then we use those values to calculate the required output. Finally, we use those same values to evaluate each answer choice to see which one yields an output that is the same as the required output. Now please note that in most cases, either strategy will work. However, you will find that the algebraic approach is typically faster, so this should be your preferred strategy. In this lesson, we will examine some tips to consider when using the algebraic approach to solve questions with variables in the answer choices. To demonstrate these tips, we will solve some questions. Now in the question shown here, we are told that a box of widgets costs X dollars and there are Y widgets per box. Our goal is to determine the price of one widget. So it costs X dollars for Y widgets, and we want to find the price of one widget. Now for some questions, it may not be obvious how the given variables must be combined to represent the required value. When this happens, one approach is to use hypothetical values to determine the operations needed to reach the required value, and then apply those operations to the given variables. So for this example, let's choose some nice hypothetical numbers to get an idea of how to find the cost of one widget. For example, what if it costs $6 to buy a box of 2 widgets? Well, if this were the case, then the cost of one widget would be $3. What if it costs $20 to buy a box of 5 widgets? If this were the case, then the price of one widget would be $4. From these 2 hypothetical examples, we should see that to find the price of one widget, we take the price of a box of widgets and divide that by the number of widgets in the box. So if it costs X dollars for a box of Y widgets, the cost of one widget must be X divided by Y, which means the answer here is D. Alright, let's try another question. Here we're told that last year the population of Townville was K, and we want to determine the new population after an increase of P%. So the old population is K, there is some increase of P%, and we want to determine the current population. Once again, if we are not entirely sure how to generate the expression for the current population, let's choose some nice hypothetical numbers to get an idea of how to determine the current population. Let's say the old population was 80 and the population increased by 10%. Using these hypothetical values, how would we calculate the current population? Well, we would take the old population and add to it 10% of 80. 10% can be written as 10 over 100, and to find 10% of 80, we multiply 10 over 100 by 80. Now that we have an idea of how to increase a population by 10%, we can apply similar operations using the given variables. So to find the current population, we take the old population, k, and add to it p% of k. P% can be written as p over 100, and to find p% of k, we multiply p over 100 by k. Now, if this expression does not match one of the answer choices, we can always rewrite the expression by first simplifying the right-hand side. At this point, you might check to see if this matches one of the expressions in the answer choices. If it doesn't, we might consider combining the two terms by rewriting the fractions with common denominators and then adding the numerators. If this expression still doesn't match one of the answer choices, we can always factor out the k in the numerator to get k times 100 plus p over 100. At some point, one of these different versions of the same expression would match one of the answer choices. The important thing here is to keep finding different ways to rewrite the expression. Alright, let's summarize. In this lesson, we learned that we can use hypothetical values to determine the operations required to reach a certain goal, and then apply those operations to the given variables. We also learned that if the expression we derive does not match one of the answer choices, we should consider writing the expression in different ways to see if that works. In this lesson, we'll examine some tips to consider when using the input-output approach to solve questions with variables in the answer choices. Now, in an earlier lesson, we solved this question in which Garth owns a total of X ties, and Y of these ties are blue. Our goal here is to determine which of the 5 algebraic expressions represents the number of ties that are not blue. So, using the input-output approach, we chose values for the variables X and Y, and then we determined that if X equals 10 and Y equals 3, the number of non-blue ties must equal 7. At this point, we checked each answer choice to see whether it yielded the target output of 7 non-blue ties. When we plugged X equals 10 and Y equals 3 into the expressions and evaluated them, we found that only one expression yielded the target output of 7. So the correct answer must be B. Now let's solve the same question using different input values. Let's see what happens if we let X equal 4 and Y equal 2. This means that Garth has 4 ties altogether, and 2 of them are blue. Using these values for X and Y, we see that Garth must own 2 non-blue ties. And at this point, we should recognize that we have a potential problem with these numbers. For one thing, we have Y equals 2, and our output value is 2. Also notice that there are several possible relationships between the 3 values shown here. For example, 2 to the power of 2 equals 4, 2 plus 2 equals 4, and 4 divided by 2 equals 2. As you'll soon see, these relationships can cause a problem when we test the answer choices. When we plug X equals 4 and Y equals 2 into the expressions and evaluate them, we see that 2 expressions yield the required output of 2. Now this means we can eliminate answer choices A, C, and E, leaving 2 possible answers. From here, we'll need to find another set of values for X and Y and plug them into the 2 remaining answer choices to see which one yields the correct output. This, of course, wastes valuable time. So our goal should be to choose numbers that will most likely yield only one matching output. With this in mind, let's examine some general guidelines to consider when choosing numbers. First, it's a good idea to choose small numbers since they're easier to work with. And it's a good idea to choose prime numbers since there are fewer relationships between prime numbers. Second, you should try to use different numbers. If you use numbers that are the same, you won't know the effect that each variable has on the resulting output. Third, it's usually a good idea to avoid choosing 0 and 1 as numbers to plug in. The test makers know that these are popular values to plug in, so they'll often create 2 or more answer choices that yield the same output. So plugging in 0 or 1 can often result in having to plug in a second set of values, and this can be a big time waster. And fourth, you should avoid using numbers that appear as given information in the question. Okay, now let's apply these guidelines to this example. You may find it useful to pause the video now and attempt the question before continuing. Okay, if we're unable to solve this question using the algebraic approach, we must use the input-output approach. So here we have someone buying some nuts and bolts, and we want to find the number of nuts purchased in terms of B, the number of bolts purchased. So let's choose a nice value for the number of bolts purchased. Well, we could say that Donnie purchased 0 bolts, but there's a good chance that the test makers will have anticipated this and created more than one answer choice that works with this value. For the same reason, we should avoid having Donnie purchase 1 bolt. What about having Donnie purchase 2 bolts? Well, this might not be a good idea since we're reusing a value from the question. So let's skip this number. For the same reason, we'll avoid using 3. Now what about having Donnie purchase 4 bolts? Well, this number seems okay, so let's go from here. If Donnie bought 4 bolts, the cost of those bolts will be 12 cents, since bolts are 3 cents each. Now we're told that the total purchase price was 90 cents, which means Donnie must have spent the remaining 78 cents on nuts. Since nuts cost 2 cents each, this would mean that Donnie bought 39 nuts with the 78 cents. So when B equals 4, the number of nuts purchased is 39. From here, we'll plug in 4 for B and see which expression yields an output of 39. When we evaluate this, we see that only one answer choice matches our target value of 39, so the correct answer here is B. Now at this point, I'd like to go back and see what would have happened if we had gone with a scenario in which Donnie bought 0 bolts. In this scenario, the cost of 0 bolts is 0 cents. This means that all 90 cents was spent on nuts, and at 2 cents each, Donnie would have bought 45 nuts. So when B equals 0, the number of nuts purchased is 45. From here, when we plug in 0 for B and then evaluate, we get 2 matches. So it's likely the case that the test makers predicted that we might try using such an easy value, and they made 2 answer choices work. At this point, we still have 2 answer choices remaining, so we have no choice but to find another value for B and plug it in. This, of course, will take some time. So in general, when using the input-output approach, we should avoid using the overly convenient values of 0 and 1. However, there are times when it might be useful to ignore this guideline. Consider this example. Here the question is long and quite confusing, and more importantly, the expressions in the answer choices are cumbersome, which means it may take a considerable amount of time to plug in values and perform the necessary calculations. In these situations, it may be worthwhile to plug in some easy values like 0 or 1, but only if it means you can perform the calculations quickly in your head. This will often allow you to quickly eliminate some answer choices, leaving you with 2, maybe 3 answer choices, at which point you can either choose to plug in another set of values or guess one of the remaining answer choices and move on. Let's see how all of this might play out. We'll begin by breaking our rule about choosing 0 as a plug-in value, and we'll see what happens when x and y both equal 0. In other words, the portfolio increased 0% from Wednesday to Thursday, and it increased 0% from Thursday to Friday. This would result in a 0% increase from Wednesday to Friday. From here, it should be apparent within a matter of seconds that when we plug in 0 for x and y and perform the necessary mental calculations, every expression yields the target output of 0%. So the test makers have obviously predicted that we might try such a shortcut, and they've designed answer choices such that we made no progress here. At this point, we might try some less obvious values, or we might try using one more set of easy values. Let's try one more set of easy values. Now don't forget, we're looking for values that we can plug in and evaluate quickly in our head. So this time, let's see what happens when x equals 0 and y equals 100. In other words, the portfolio increased 0% from Wednesday to Thursday, and then increased 100% from Thursday to Friday. This would result in a 100% increase from Wednesday to Friday. Once again, these values make it very easy to mentally plug in 0 for x and 100 for y, and then perform the necessary calculations. When we do this, we see that we have 2 matches. Great. At this point, if we're short on time, we should be happy with the fact that we now have a 50% chance of guessing correctly. On the other hand, if we choose to plug in another set of values, we need only check the 2 remaining answer choices. So let's do that. To begin, let's say that on Wednesday the portfolio was worth $100. For the first increase, let's say the portfolio increased 50%. This means that on Thursday the portfolio was worth $150. From here we need to choose a nice percent increase from Thursday to Friday. So what's a good value? Well, we're increasing $150 by some percent. So we want a percent that works well with 150. What about 20%? 20% of 150 is 30. So after a $30 increase, Friday's portfolio value is $180. Now, if the portfolio's value went from $100 to $180, this represents an overall increase of 80%. In other words, when x equals 50 and y equals 20, the overall percent increase is 80%. Now at this point, we could take our 2 remaining answer choices and plug in 50 for x and 20 for y, and see which one yields the target output of 80%. However, notice that evaluating this expression with those values will take a lot of time. On the other hand, testing answer choice C will be very easy. So let's do that one first. When we plug in 50 for x and 20 for y and evaluate, we see that this expression does not yield the target output of 80. So we can eliminate answer choice C. Now that we've eliminated 4 of our 5 answer choices, there's no need to check answer choice B, since it must be the correct answer. Okay, let's summarize. In this lesson, we learned some general guidelines for choosing numbers to plug into the answer choices. And we learned that there are times when we can quickly eliminate answer choices by plugging in easy values.